Okay, welcome back to part 2 of rationalizing denominators, or numerators if that's what the problem calls for. Depends on the context. Actually, our first example here, we're returning to example 5 from a previous 10-minute video. We're going to rewrite a function. We're going to find out that we have variables in our expression now. We're going to rewrite this function by rationalizing the numerator. We find the square root in the numerator. We're going to use the same technique as we'd used before. We're going to just multiply this fraction by 1, something over itself, and not change the value of the function, or we're going to try not to change the domain of the function. And so as we saw in the last video, we look at the expression that has a square root in it. We create the conjugate of that expression by keeping the first term, keeping the last number or term, and just changing the operation in the middle. If we multiply by the sum in the top, we have to multiply by the sum in the bottom. Okay. In the numerator, we have a binomial times a binomial, and so we're going to use that technique called FOIL that tells us how we need to multiply so that we distribute all the terms. When we take the product of the first two terms, we get the square root of x plus 1 squared. The square root goes away, and we're just left with x plus 1. When we multiply the outside two terms, we get the product positive 3 times the square root of x plus 1. When we multiply the inside terms, we get negative 3 times the square root. And finally, when we multiply the last two terms, we get a negative 9. In the denominator, I'm going to leave things factored. You'll see in a moment why we do that. So I have a factor of x minus 8, and then I have that factor that was our conjugate from before. So are you looking at that numerator? And do you see the opposites that are going to add up to 0? Okay. So you may be looking right here in the middle, the outer product and the inner product. They're opposites. So they're going to add up to 0. Okay. And while I'm here, I see that I use some grouping symbols, and those grouping symbols can fall away because it's just a sum. Okay. So in the numerator, we have x plus 1 from here, plus 0, and we need to subtract 9. In the denominator, I still have a factor of the difference and the factor of this sum. When I collect like terms in the numerator, I see I have x minus 8. I have a factor of x minus 8 in the denominator. Looks like we're going to have some things that are going to cancel. And that's what we were going for with this technique. Okay. Now I have to be careful. If I want to cancel x minus 8 over itself, I'm going to have to tell the reader something. I'm going to have to remind the reader that x cannot be 8, because we do not want to change the domain of this function. So if I cancel x minus 8 and x minus 8, I'm left with the factor of 1 in the numerator. And all I'm left with in the denominator is the sum. Oh, and we again remind the reader that x cannot be 8 when we use this expression to evaluate. All right. So we rewrote the function. No longer does it have a square root in the numerator. It has a square root in the denominator, but depending on the context of the problem, this can be just fine. Okay. So example 5 complete. Okay. Example 6. Pull that down so you can see that again. Got the paper there. Same directions. Example 6 is a ratio that has a square root in the numerator again. So depending on the context of the problem, we might want to get the square root out of the numerator, and we won't care if there ends up being a square root in the denominator. And so we want to multiply by something over itself, and we want that ratio to be 1. So it can be anything over itself. And what's going to be more convenient is to choose the conjugate of that expression in the numerator. Okay. So the conjugate of that expression is going to keep that first product, 2 times radical x minus 5. It's going to keep the last constant, 4, but we're going to change the operation in the middle. Okay, and we're becoming familiar with the reason we multiply by a conjugate. When we use FOIL to distribute, the first terms are going to multiply and the radicals will disappear. The last terms will multiply eventually and we'll get a perfect square, but the outside and the inner terms will add up to 0 and the expression will simplify immensely. We also learn from experience that in the denominator we don't want to distribute because we're looking for some terms that are going to some factors that will cancel. So let's leave the denominator factored. Let's multiply the first terms, 2 times 2, and the radical times the radical. The outside and the inside products will add up to 0. So that leaves us with the last product. Okay. We multiply through the parentheses. I'm going to keep the denominator factored as I had before. And we learn to look for something that may cancel top and bottom. It may not. So I collect like terms and I get 4x minus 36 on the top. So that looks like it might be related to my factor of x minus 9 in the bottom. And if I recognize that there's a common factor of 4 in the numerator, factor out the 4, then indeed we have some factors that are going to cancel. Okay. Now, if I'm tempted to cancel x minus 9 divided by x minus 9, I need to tell the reader that x could not be 9 to evaluate that expression. So our simplified answer has a 4 in the numerator, it has our conjugate in the denominator, and we need to tell the reader that x cannot be 9. Okay, that's the end of our 2 examples rationalizing the numerators of functions, and that was part 2 of 2 videos. Thank you.